When we were putting it together today, we decided that since this has been such a long project, and we refer to it pretty easily between phase 1 and phase 2, or BWM1 and BWM2, but there may be some people in the room that aren't familiar with that. So my goal is really just to give you a sense of the totality of what we've worked on in the past 7 years or so, and also just touch base on how some of the different pieces fit together. You're going to get a lot more information today on each of those pieces, so I'm not going to go into depth on any of them, but just to touch base on them. So how I'm going to do that is just kind of 3 pieces, why we got involved in blue carbon and kind of the guiding principles that will kind of stand by throughout the day, hopefully, and then a little bit on BWM1, the first project, the science, the methodology, and the modeling, and then BWM2, which is what we're wrapping up now, the model of generalization, the science again, and the carbon market feasibility analysis. So just to kind of set the stage, the reason we got into this work is really because of this. Because we, I think everybody in this room recognizes that we're living in a changing climate, and that acceleration is just, phenomenal, and that we need to bring everything to bear, every option to bear. And although blue carbon is, in some cases, a small piece when you talk about other things, it is a piece. And so identifying, bringing every option to bear against this massive problem we're facing as a society is really one of the reasons, the driver that gets us excited about these type of work. And yet, I put carbon storage down here. It was never just about the blue carbon, so we don't want to lose the sense of that. I mean, looking out the faces in the room today, I know most of you, I don't think we will do that, but to understand, it's not just a carbon project. We're not just promoting wetlands restoration and tidal restoration and seagrasses and mangroves because of the carbon benefits, but because of all the ecosystem services that we already recognize out there. And when we talk to community members, we talk to teachers, we talk to students, it's really about talking about all these things, but bringing out this additional carbon piece that people didn't really appreciate. So even when we get into the feasibility analysis and we're talking about money and we're talking about markets, it's never just about that. It's about the totality of the ecosystem services that we get from these phenomenal places. And so those were kind of the guiding principles for the team throughout. This is my only slide that I left in there kind of just in generality about where the carbon is in a New England salt marsh. Many of the people in this room understand blue carbon, but just as a touch base that throughout the project, we're looking, when we talk about carbon, we talk about carbon exchange, we're talking about greenhouse gases, we're talking about what's happening in the living biomass above the ground, the living biomass below the ground in the roots and rhizomes, the stored or dead carbon in the marshes, and then also the gas and those gases, greenhouse gases, as they're dissolved both in the air column and in the water column, and how that's interacting. So it's a complicated process, and that carbon is moving through different pieces, and some's coming and some's going. But you'll hear different pieces of that throughout the day. But that's the only kind of thing on blue carbon I had. We'll have some questions at the end if anybody has questions, but I figured this group didn't need a lot of background. Okay, BWM1. It was really a project that was put together to look at wetland restoration and greenhouse gas benefits with a heavy nitrogen component. So everything was done in the Waquoit Bay system in Falmouth and Mashpee. At that point in time, these are the 4 sites that were used. It was a very local project because we were looking at a different nitrogen gradient. So when we talk about BWM1, where the model was initially devised and a lot of the science tested, it was really a small-scale site around the Waquoit Bay system. So those were the field sites that we had under that project. A lot of the science was new, a lot of the technology was new, a lot of the applications were new, and so this is some of the vertical fluxes chamber work that was done under BWM1. We were also looking at lateral fluxes, or those greenhouse gases as they're dissolved in the water column and come in and out with the tides through small tidal creeks. And as we talked about, the below ground storage, both in living and dead biomass through. Sorry. Oh, I'm sorry. I was just trying to stay. I was afraid that thing was going to buzz again, but maybe I'm okay in this spot. I'll find my danger spot here. So also, a lot of work done on elevation work and elevation capital, which you'll hear referred to as well. So, and what that project really was looking at was building a total carbon budget of these small salt marsh systems. And although they're small, using a place like Waquoit Bay is a great place to do that because you can control the watershed in that case, and then take that and scale that up and apply it to much larger systems. So very intense work done, very cool science done under BWM1 that continued in the BWM2. And then how that field science fits into the modeling is really the question of what do you need to know to predict carbon storage in these blue carbon systems. And these are some of the parameters that we were looking at and how they fit in. I will tell you from BWM1, if most people again in the room probably already know this, but the nitrogen component was not critical. That we were not finding across the nitrogen gradient a big difference in the greenhouse gas sequestration and storage in these systems. I'm going to take a peek ahead here. And then that model fed into lots of output products. That data fed into a lot of output products like the model itself. And then that model then went into some things like the blue carbon calculator, which was an EOEA initiative here in Massachusetts. So this is some of the products that came out of BWM1. Also with us today, Tana Marie mentioned that we have folks from Restore America's Estuaries who are one of our major partners on this. And at the same time all that science and modeling work was going on, there was a greenhouse gas offset methodology done. So anytime you're going to work with carbon markets, there has to be a protocol or a way to bring these credits to bear. And that didn't exist before this first project. And so that was being developed alongside, and that figures in heavily into what we'll be talking about today, because the way we're talking about feasibility analysis and carbon projects, they wouldn't exist if there wasn't an accepted methodology out there. And that was developed under the first project. So we get the end of, we'll try not to read that yet. We get to the end of BWM1, and we're kind of left with some really cool stuff. The science had been really great, even though the nitrogen piece hadn't panned out. What was very exciting was the methane piece. So you're going to hear a lot about methane today, so I'm not going to go into a lot of detail. So we needed further exploration on that piece, on tidal restoration and the change in methane production from fresh and brackish wetlands back to saline wetlands. And so that piece, and also all the work I had mentioned about developing the protocols, now we had tools that could actually be used to develop a full carbon project in a blue carbon project. So the BWM2 summary, I actually took this from our grants. It's always nice to go back and look at your grants, what we were proposing to do, and so some of that's going to be the day. But essentially it was two major pieces, and it was to work with the existing model that had been developed under the first project to predict the greenhouse gas exchange across a wider range of coastal wetlands, both salinities, restoration times, and physically looking up and down the mid-Atlantic and New England coasts, because I mentioned that first project had been just Waquoit based. And then additionally taking that protocol and taking additional science and bringing and creating a feasibility analysis on a true carbon project. And you're going to hear that happened at Herring River, and so again you're going to hear a lot about that today. But those were the two main summaries that you're going to hear about today, and that's why, because that's what we were being funded to do. And the tasks were collect additional data from what we call Tier 1 field sites, which are New England sites, get existing data sets from what we call Tier 2 sites or other cooperators, other PIs sites across New England and into the mid-Atlantic, and then generalize that model against new regimes and scale it up. Work with a lot of stakeholders. This is Herring River stakeholders on a carbon project. Produce the feasibility analysis using data from the field and the model, and then also produce a lot of output pieces, including the curriculum for teachers and students, which you can get a chance to see. There's a table out on the just to the right here when you come out that has a lot of the curriculum pieces there, and I think Joan's going to be at the table. And we've worked with hundreds of teachers, and those teachers have worked with thousands of students using this curriculum in the classrooms. And then some of the products you're going to hear about today, the model, the feasibility analysis, and then seminars like this, and we've been doing lots of discussions about this. So, and so those Cape Cod sites were distributed throughout the Cape now instead of just Waquoit Bay. So you'll see actually that Eel Pond site down in Waquoit Bay down in the lower left we did not use. So, and then there were also sites in Rhode Island, so those were considered our Tier 1 sites. And then the outputs and outcomes from this were to, again, create that verified generalized model, which we're going to go over this afternoon, the feasibility study, which you're going to hear about this afternoon, and then always we're trying to increase the awareness of blue carbon and the benefits of ecosystem services. Again, going back to those guiding principles I talked about initially. The interpretive elements, there are signage, there's fact sheets that are available, there's lots of stuff on our website. I would encourage you to go look for those things and use those things. And then really working with resource professionals who are managing the systems to mix in this blue carbon, this carbon sequestration benefit into their daily work. And then I mentioned the curriculum activities that you can see there. So that's really what our guiding principles and our goal was throughout the project. And I hope now you have a sense of kind of what happened in Project 1 and what happened in Project 2 and how they tie in together. And now you're going to spend the rest of the day learning a lot more about those pieces. So I think I have. Oh, the other thing is, I just want to mention, Tana Marie said there were a lot of people that we kind of look at our team now, not just from this project, but from both projects. So there's some people who are in this picture that aren't here with us today, but it's also, there are, many of us are in the room today. And this is a BWM1 picture, but it kind of shows how we all age out over this project too much. But nonetheless, it's been a big project. It's been really interesting intersection. So with that, I'll just, if anybody has any questions, I think I have a minute or two for questions if needed. So.